Hi, my name is Shayne Boyer. I'm here with Dan Roth, he's PM on the ASP.NET team, and we're going to be talking about Razor components.
Razor components.
So Dan, what are Razor components?
Razor components are a new feature in .NET Core 3.0 with ASP.NET Core, where you can now build interactive client-side web UI using just .NET and C#. You don't have to write any JavaScript.
No JavaScript?
No JavaScript.
So how am I getting all of my data down to the browser?
Well, with Razor components, you have some flexibility on how you do that. You can use normal patterns that you would use with any front-end JavaScript framework. You can have some APIs on the back end implemented in ASP.NET Core, of course, or actually anything you want. And from the Razor component code, you can then call those APIs and pull down some data and just handle it directly in .NET code running directly in the browser. We call that model Blazor. That's the .NET running in the browser on top of WebAssembly. Or you can take the same components and you can run them server-side on your servers and have all the UI interactions handled over a SignalR connection. In which case, if you want to, you can talk directly to the database then, because your components are running right there on the server. They can access the database and then render the UI back down to the client. We'll handle all the UI interactions over that SignalR connection.
Okay, so this is kind of like a total framework for front end, back end, all in C#.
Yep, I mean, Razor components specifically is about the client-side UI and interactivity. But because you now have that client-side story, if you combine it with our existing server-side story, you now have a full stack .NET framework for implementing web applications. You can share code on both sides of the wire. Both sides will support .NET standard libraries. So if you want to have your model types and your validation logic living in a common assembly that's referenced by both sides of the wire, you can do that with Razor components.
Okay, so you said C# front end, back end. So what are some of the, like you mentioned a few of the reasons why I've got my C# on the front end, the back end, same models. What are some of the other reasons why I would want to use kind of C# across my entire stack instead of maybe JavaScript or some of the other technologies on the front end?
Yeah, no, I think it's a reasonable question. Like we have a very vibrant JavaScript ecosystem. There's Angular, there's React, there's Vue, there's all these frameworks and NPM packages that you can use if you're writing JavaScript. And that's perfectly fine. We support actually a bunch of these frameworks with ASP.NET Core today. If you want to create an Angular app with an ASP.NET Core backend, you can do that. If you want to do React, you can do that. I think the question becomes though, like how many different tool chains and languages do you want to have to learn and know in order to just be productive writing a web application? If you're already a C# developer, .NET developer, you're familiar with the .NET ecosystem, then a Razor component-based solution can make a lot of sense. You get to write in your sort of native tongue. You know C#. You can use that language. You know the core libraries already. You can leverage that knowledge. You get Visual Studio as a great tool chain. You get MS Build as a stable build system. You get to use the things and the skills that you already know to be productive with your application. That can be one benefit. But even if you're not a .NET developer today, I think there's still good reasons to look at this model. I mean, C# in of itself, I think, is a great language. It's modern, it's innovative, it moves at a rapid pace. There's lots of things to like about just the language. You get a lot of stability from .NET, like the core libraries that you're using, those are .NET standard. They're standardized. They're not going to change. The build chain that you're using, it's not going to change. You get that layer of maturity and stability that you then can build upon, as opposed to wondering, in 6 months, the JavaScript ecosystem moves pretty fast. What's going to be the next framework or the next tool that I'm supposed to be using, and am I going to be ready to adapt to that? We think with using .NET for client-side web development, we can give you a productive foundation to really build on that you can trust for the next 3, 5, 10 years. Yeah, so I think there's a lot to like about using .NET for web development full stack.
And you mentioned tools too, so something like Visual Studio where I've got my debug experience, I can F5, I can hit my breakpoints, server-side, client-side, and have that same kind of fluid experience.
You'll get, today we already have a really nice Visual Studio editor experience. When you're working with Razor components, you get completions and you get debugging through, you can actually debug your Razor components, if they're running in the browser, like through Blazor and running on WebAssembly, we've set up a debugging system where you can step through your C# code directly in the browser. We plan to also wire that up to Visual Studio so that you can attach Visual Studio to C# code running in the browser on WebAssembly directly from VS. And then for cross-platform developers, if you're running on a Mac or on Linux, we are just recently previewed support for doing Razor component development with Visual Studio Code. So if you want to .NET New a Razor component-based application, and then do the editing in Visual Studio Code, again with great completions, a debugging experience, you can do that too.
Okay. I want to dig in a little bit because you mentioned there's really two different things we're talking about here. We've got Razor components, which runs on the server, and then we've got Blazor, which runs in our client.
Yeah.
So what are the kind of the differences between the two, and kind of maybe benefits or not benefits between having an app that runs either?
Yeah, I think it helps to have a little history and context there. Okay. I mean, as we started looking at using .NET for client-side web development, Blazor is really what came first. So WebAssembly was this new, really cool standard where you have this low-level bytecode that's now supported by all browsers. It's standardized. As long as you can compile your code to WebAssembly, you could now get it to run in any browser at near native speed. And that really just opened the door to now run different kinds of things in the browser than you ever could before. It broadened the developer ecosystem. So we wanted .NET to be able to play in that space and have a really good story for running .NET code on WebAssembly. And that's how the Blazor experiment really began. And we started investigating, well, let's build a .NET runtime in WebAssembly, see what that looks like. Okay, and then let's now build a UI framework on top of that. That's where the Razor component model really came to be. And we experimented with that for about a year to see how that model would play out. So running your components completely on the client was the initial vision of what we were trying to accomplish. As we worked on this component model, the components follow a lot of the patterns that actually are maybe familiar if you're using existing front-end JavaScript frameworks today. Right. They render into an in-memory representation of the DOM, like of the render tree. And then the framework actually takes care of comparing what was just rendered with what was rendered before, and then calculates a diff very efficiently, and then only that diff actually gets applied to the live DOM. And that's what allows the UI to feel fast and responsive. We followed exactly that same pattern with Razor components. And the nice thing about that is it means that the component rendering logic is now decoupled from how the UI actually gets updated, which means that you can run the components actually anywhere. They don't have to run directly in the browser right next to the DOM. If you wanted to run the components like in a web worker, still in the browser, but on a different context, and then manage the UI interactions over and event handling over messaging. You could do that. That takes the components off of the UI thread at that point. You can even run those components in a completely separate process, and that's where we started experimenting. Well, what if we took the components, and instead of running them in the browser on WebAssembly, what if we put them over here on .NET Core on the server? And then we just set up a real-time connection, a SignalR connection with the browser. Now all of the UI events, we pump them over to the server. The components handle them server-side. They do their rendering thing. You calculate a diff, and then we just serialize that diff very efficiently back to the browser so that the DOM can be updated. That has a bunch of benefits. Well, for one, it didn't have any WebAssembly dependency. The WebAssembly .NET runtime, that's the biggest work item for Blazor, making sure that .NET runs really well in the browser, and we're making lots of progress there. But it was pretty obvious that was going to take more time. By running your component server side, you just run on .NET Core, and you've got a fully functioning .NET framework you can just take advantage of. Other benefits: the startup performance of the app is now actually significantly faster, because you don't need to download a whole WebAssembly runtime into the browser. You just need a little bit of infrastructure JavaScript that sets up the SignalR connection and handles pushing the UI events up and receiving the DOM diffs back and applying them. So the app actually starts up really, really quick. So that's nice. And then you're no longer running in a browser sandbox server side. You've got the full power of .NET Core. If you want to talk directly to the database at that point, you can do that. It can really simplify your app's architecture. Now doesn't solve every scenario. This model has also some trade-offs. Like one of the trade-offs is latency. Like every UI interaction now has to go over a network hop. If you're trying to do something where like every time you hit a key on the keyboard, you want the components to do something, well, you got to send every keystroke up to the server, and every UI update needs to come back down. So latency is one issue. There's also some scale-out concerns, like you now have a connected client model. I think of it often as like a dumb terminal for a mainframe, or maybe like a Cisco-style model where you're just the browser's basically just handling UI concerns, and it's all the smarts are actually server-side, which means you have to maintain a connection for each client. If you have lots and lots of clients, that can become a scale-out problem. Fortunately, we decided to build on SignalR, which means we can leverage existing services like the Azure SignalR service, which can then handle the broad connection scale-out for you.
And it's probably just a quick change in our client, where we're just changing instead of running my hub in one place, now I'm going to run it in Azure SignalR, and I can scale out easily.
Yeah, look, it's literally just one extra line of code and a line of config inside your application, and now your components hub, it's just a normal SignalR hub underneath the covers, is being hopped through the Azure SignalR service.
Now you mentioned the Razor components, and one of the examples you gave was, every time I hit a keystroke, I don't want to have to send that event, right? Because now we're handling the events instead of on the client side. In a Razor components model, I'm handling the events on the server. Yep. So if hello world, I'm handling every one of those keystrokes up there. It sounds as if we are following almost a web components type model with the same thing, where maybe not web components, but like the other SPA frameworks is, now you're giving me the ability to break up my app into multiple pieces, but I have to be cognizant of how many of those components I'm really putting together, because I have to manage all those events in certain places.
Well, the apps are certainly meant to be highly componentized. Like that's the one of the nice things about Razor components compared to some of the other technologies that we have available in ASP.NET Core. Is you now have a real UI component model. If you want to take a little chunk of UI and package it up in a NuGet package and ship it to someone else, and they can just reuse that, you can do that. And your app is meant to have lots and lots of components that are all calling each other and being used by each other. With Razor components, the real concern comes with the latency of that UI connection, that SignalR connection to the server. If you want, you just have to make sure that the hop between the client and the server has as low latency in terms of your network topology as possible. You'll want to get those apps close to the clients if you want that to really feel snappy. But there are lots of apps where you won't even really notice, particularly if you're over a good network connection, it's close by, and you're doing like a line of business application with lots of forms over data and just some UI interactivity. The Razor components model is a great way to be very productive, still get to do highly interactive flows without having the extra cost of having to adopt the JavaScript build system and language and building up that additional expertise.
Yeah. So it sounds like when it comes to performance, we don't like to go back to it depends. But when it comes to looking at your app architecture, if I'm going to do client side, a Blazor implementation or a server components, if I'm going to create a component and maybe distribute on a NuGet package, that might be a good model for me. Or if I'm going to break up my app into multiple components, the Razor components might be the best model. You really have to evaluate, how is my app going to be put together? Where's the best place to run it? How do I want to scale? Is it going to be an internal app where it's just maybe 25, 50 users? Or am I going to go explode and I need to use something like Azure SignalR service and really scale out my connectivity to the clients?
Yeah, I would like the way I would think about the decisions matrix there is, if you really want to leverage the client process, you want to support things like offline. A server-side Razor component app can't do offline because it requires that connection to be present. If you want to leverage the client process to offload the UI rendering to the individual clients, then Blazor running on WebAssembly, that's what you're gonna want to use. And then you can do things like, if you want to do a progressive web app and put it in the the Microsoft Store and have it be installed in Win 10, you can do those types of things with the full client Blazor model. If you instead prefer to try and you actually want to keep the code on your server, like some people are concerned about well, my app code is actually going to go down to the browser. Do I have things in there that's like my IP, or I don't want them to be able to disassemble those assemblies. I'd like to keep some maybe particular data server side, and don't want to have to bother with wrapping everything in an API. Then the Razor component model becomes very compelling. One demo we like to do is where we take ML.NET and Razor components, and you train a model with ML.NET, and that machine learned model might be something that you don't want to share with the world. Like it was with your own data. It's a piece of proprietary technology, so you don't want to actually going down to the browser for each client. Well, you could just keep that thing server side, run ML.NET on the server in your Razor components, and then the client never sees it. You've kept it on the server. Those types of scenarios can be very compelling. You also may have older browsers that don't support WebAssembly. Razor components with that SignalR connection works fine as long as you can establish some sort of WebSocket connection or something that we can do SignalR over. Then you can make it work with the server-side model. The client-side Blazor model only works if you have a more modern browser that supports WebAssembly. Okay. The biggest example would be like if you need to support IE. IE doesn't support WebAssembly, and it's never going to support WebAssembly, so you'd have to use the server-side Razor component model. Okay.
When you're talking about, you mentioned like I don't want my IP going down to the browser, down to the client. That kind of dovetails a little bit into security. What are the security models around some of this, some of the technology we're getting into, and should we be concerned or should we not be concerned about maybe the context of my app running in, a client's browser? Do we need to worry about other sandboxes that are protecting us from this? I mean, how are we looking there?
Yeah, so security is a great question. A lot of people get a little worried when they see a Blazor app with DLLs coming directly into the browser. I mean, that's how a Blazor app works. It's a .NET runtime running in the browser that runs just normal .NET assemblies. They think, well, can those DLLs now do things on my machine that you wouldn't normally want a web-based application to do? And the answer is no. Like all of the WebAssembly-based code, including the runtime and the assemblies that it's executing, that all runs in the same browser sandbox that JavaScript runs under. So Blazor code, even though it's written in C# and it looks like DLLs, it can't do anything more than you could do with normal JavaScript. Okay. Conversely, anything that you can do with JavaScript, you can also do with a Blazor application. If you want to call into any browser API, or if you even want to call into an existing JavaScript library, you can do that from your Blazor app using a JavaScript interop mechanism. That's very common. In fact, people can take like JavaScript libraries or APIs, sort of shrink wrap them in a .NET API, and then you can ship that as a NuGet package. And then anyone can now call that JavaScript call or that browser API as if it was written in C# and .NET, which is pretty fun. So you can't go have access anything on the file system that you want. You can't open arbitrary network connections because you're running in the browser. You're running within that same sandbox. Now, if you take the same Razor components and instead run them server-side, well, now you're running on .NET Core. You're not in the browser sandbox. So server-side, those components, they can do whatever they want. They can talk to the database. They can open network connections. And that's one of the nice things, actually, about the server-side hosted model is that you're no longer bound by the browser sandbox and the client process. At the same time, you're not actually leveraging it either. Like you're paying with your own server resources for things that you could be pushing off to the client.
So if I have let's say I go down one road, my development team says, you know what, we want to go full-on client-side development. We don't mind if we're shipping our whole app and down to the client, and we're completely happy with that. And then C-level exec comes by and they go, we're not cool with this. We need to go back to the server. Is it painful for us to make that change as a development team?
So one of the beautiful things about Razor components is whether you're running in the client or on the server, the component model is exactly the same. Like Blazor literally depends on the same .NET assemblies that define what a Razor component is that you're using when you run Razor components on the server. So you can take the same components, run them client-side, and then flip the app to run server-side and vice versa. Like both are totally possible. You do need to make sure that the component implementation is insulated from where it's running. Like if you wrote a component that talks directly to the database, and then you flip that component to run now in the browser, well, the browser's not going to be able to open an arbitrary connection to the database, but you can have that component instead talk to like a service abstraction that was injected using DI, and then depending on whether you're running client-side or server-side, you just swap in an appropriate implementation of that service interface so that, well, here I'm going to talk through an API through my database. If I'm running client-side, if I'm on the server, then I have a different service implementation that just talks directly to the database. Those are the types of things that you would need to do.
Okay. You mentioned a few moments ago about being able to run in different contexts. You talk about running out, maybe in a web view. Am I able to create maybe an Electron app inside of a maybe desktop? And be able to do that as well?
I mean, you can run the Razor components in any process, and as long as you have a channel of communication to something that speaks, web tech like HTML, you can use this tech. So one experiment we've been working on is you take your Razor components, you run them on a .NET Core process, and then you have that process talk to an Electron process over an IPC channel. It's literally the same setup as like Razor components running on the server, just with a shorter connection. It's not using SignalR, it's just using a little IPC channel, but the model architecturally is exactly the same. And what it means is that you now can write a desktop app using .NET Core actually, using HTML, CSS, using normal web tech, and that application is now a cross-platform desktop app. It can run on Windows, it can run on Mac, it can run on Linux, it can do anything on a machine that you would normally expect to be able to do from a desktop application, because it is a desktop app. It's just running directly on the machine. Nice. So that's one thing that we have been playing around with, and there's samples that you can download and try out if you're interested in the Electron model. This model can be extended to other app types as well. Like you can imagine doing something very similar in a mobile application where you have these Razor components running on, say, like the Xamarin runtimes on a mobile device. Again, talking to a web view. Like Electron is basically just a web view, a Chromium shell wrapped in a process. Well, in a mobile app, you can imagine doing the same. And now you have a mobile application implemented with .NET, web technologies, and a cross-platform UI stack. Those models are totally possible. We've been playing around with them a lot. Right now, we're focused pretty heavily on the web app space. We want to make it so that you can build full-stack web apps with .NET and C#. But we are looking at these other application models as well.
Cool. So what's the roadmap look like? Where are we going with this? I know we're at Razor components now. We're still working on getting the Blazor stuff kind of put in a box. And where are we looking down the road? When does it ship? When are we getting it? When can you use it? When can I build an app with it?
And we kicked off the Blazor experiment like a year and a half ago. Yeah. We then took a huge chunk of what Blazor was, the component model, and we are putting that in .NET Core 3.0. So .NET Core 3.0 now has the component model. We call that Razor components, and that will ship with 3.0. That will ship sometime later this year. Okay. Blazor on top of WebAssembly really depends on this when the WebAssembly runtime is ready. That won't be done for .NET Core 3.0. We're working on both in parallel. Like it's not like Blazor has been put on hold while we work on Razor components in .NET Core. We are shipping releases of both in parallel with every update to .NET Core 3.0. But the WebAssembly runtime we expect to finish sometime after 3.0 ships. Exactly when, we're still we're figuring that out. But hopefully by one date's been thrown out is by the end of this year, maybe early next year. That's as soon as possible. As soon as we can get the WebAssembly
as fast as you can type
done.
It out, right?
Yeah,
get it done. All right, so if anybody wants to try this out, where do we go to get the samples, docs?
So if you want to try out Blazor or Razor components today, for Blazor, I would point you to blazor.net. Okay. That will bring you to our Getting Started page for installing getting your machine set up with .NET Core 3.0 and Visual Studio and the Blazor templates. If you want to try out Razor components in .NET Core 3.0 specifically, then all you need to do is go to .NET, get the latest preview of .NET Core 3.0, install that. That has the Razor components templates already built in. You can just .NET New your first Razor components app. And if you want to use Visual Studio, you'll want to get the latest update to Visual Studio 2019. Okay. Install that, and that'll get you the tooling for working with Razor components as well.
All right, and the tooling's included in Visual Studio 2019?
Tooling is included for Visual Studio, and the same tooling actually works for Blazor apps and for Razor components apps. So once you've got Visual Studio 2019, you're all set to go. To get the Blazor templates, there's just an additional Visual Studio extension that you install so that the templates show up in Visual Studio, but all the tooling is already there. If you're not on Windows and you're not using full Visual Studio on Windows, you can also try out Visual Studio Code. The C# extension for Visual Studio Code has support for Razor now, and also working with Razor components. You can use that to work with a Blazor app or a Razor Components app on Windows, Mac, or Linux.
Awesome. Well, I learned a lot today. I'm certainly going to go back and try it out. So I appreciate you spending time with me.
No problem. You should. It's a lot of fun.
Cool. Thanks, man.